Good morning, everyone. Good morning, friends. So, today we are going to start a new playlist. Okay, so this is with respect to neural networks. Right. So, before that, can you quickly confirm is my voice clear? Can you hear me properly? Yes. Okay. So, once again, I welcome you, all of you, to the new playlist that we are going to learn neural networks. So, as part of this playlist, we are going to start deep learning algorithms. Okay, so in the previous playlist, I have explained the concepts of machine learning. Excuse me. So we have understood the concept of machine learning. So friends, if you are joining for the first time, you know, just go through our previous, you know, playlist where we have covered Python. Okay, then EDA, exploratory data analysis, then data cleansing, SQL, Power BI. So why am I talking about all these playlists that are part of our YouTube channel is if you are going to be if your dream is to work in the space of artificial intelligence, right? So interviews are expecting some good amount of knowledge on the topics that I have mentioned. So just go and have a thorough knowledge, okay, gain good amount of skill on these particular topics, and they are available for free in our channel. And post completing these sessions, we also started the sessions on machine learning. So where we have two playlists. One is on classification, and the other one is on regression. I hope it's making sense. And today we are going to start a new playlist, and which is on neural networks, right? So anyone joining here, do you have any understanding on neural network? What exactly is neural network? That's okay. Even though if you're wrong, I'm here to correct you, because as we are learning, okay, let us be very clear with respect to the concept. So I'll explain one more time. So as part of this particular week, we are going to deliver sessions on neural networks. So in the morning forenoon sessions, we'll have sessions on neural network topics. Okay, and afternoon sessions, I'll be delivering sessions on NLP, natural language processing. So friends joining here, you know, even though if you are the connections, your friends, whoever might be interested in learning these new emerging technologies, okay, the important topics as part of artificial intelligence, ask your connections to join these sessions, and be clear with respect to the topics. Ask them to learn. Right. I hope the agenda is fixed. Okay, it's clear, right? So we are going to learn neural networks. So what exactly is a neural network? Is the first question that we get in the mind, because entire deep learning entire deep learning, you know, all the algorithms, it might be transformers, CNN, RNN, LSTM, GANs, GRUs, whatever it might be, all of them, they rely on neural networks. But majority of us, we are not good at what is exactly a neural network. So let us understand what is a neural network, what are the core components that we have in neural network, how neural network gets trained. Okay, then we also have some important topics like activation functions, different types of activation functions that we use in neural network, then optimization algorithms as well. Okay, right. Excuse me. Let us discuss the agenda first. I'll give you the overview of deep learning. What is deep learning? We'll understand first. Okay, so probably all of us are aware of AI. Okay, then ML, but only few, not everyone will be aware of DL, deep learning. So let us initially get an overview. Let us understand what is this deep learning. Okay, then we'll understand neural networks. We'll understand neural networks. Then we'll also understand how these neural networks work. Okay, and probably under the working of neural networks, we'll discuss the architecture. This is very important. Okay, if you understand the basic architecture of network, you can map, you can assume the same way. Okay, that other neural network types is also going to use. Then the core components like weights, bias. Okay, what are these terminologies? We'll understand. Post understanding weights and bias, we'll go and talk about activation functions. Okay, under activation functions, we'll discuss the types. Okay, and also which activation function should be used in which layer, and you know what problem we face exactly with respect to each and every type of activation function. We'll also discuss. Okay, right. Next to activation functions, let us discuss loss functions. Okay, so what are the different types of loss functions that we use? How this loss is calculated? What is cost function? We'll discuss. Okay, next we'll also discuss gradient descent algorithms, the optimization algorithms that we have. We'll discuss them. Okay, the different types, and finally types of neural network and the applications of neural network. So all these topics probably I cannot complete in today's session, right? So it can be extended till tomorrow as well. But let us understand all the core components. If you are able to understand, with respect to one neural network, the same can be implemented in other neural networks as well, right? So let's get started. So friends, what do you mean by artificial intelligence exactly? Because you see the image. So what exactly you mean by artificial intelligence? Yes, all of us, we are aware of human intelligence. What is exactly human intelligence? We being humans will have some intelligence, right? Okay, so using that intelligence, we are going to take right decisions at right times. Okay, we are going to solve complex problems, right? Again, we have an ability to decide what is wrong, what is right. So this is just because of the intelligence that we have. If we are going to use the same intelligence, and if you are mimicking that intelligence to a machine, that becomes an artificial intelligence. Okay, if you are going to train a machine where that particular machine is going to you know come up with some output, like it goes and takes some decisions. Okay, if not, it is capable of doing problems, solving some complex problems. So who is going to do all this? Are we being humans, are we going to do this? No, machines. The best example that I generally give is driverless car. If you take driverless car, okay, so is there any driver sitting in the driverless car? No. The name itself says it's a driverless car. No driver is required. So what does driverless car do? Obviously it's a car, right? So it has to be on the roads, on the lanes at some time, right? So when a driverless car is coming on a road, you know, assume this is a car, right? This is driverless car and it's coming towards right side, and there is a person standing on the road. Okay, what it does? Will it hit the person and go? No, right? So obviously, depending upon the speed at which it is coming, and moreover, the distance between the person, the object, and the car, it calculates everything, and within the time, within fraction of seconds, it is capable of taking right decisions. But who is actually providing the decision? Are we providing the decisions? Are we saying to the car that apply brakes or honk or steer to the left or steer to the right? Who is actually providing some kind of inputs? Are we going to do by sitting inside a car? No. The car itself, driverless car itself, is going to take the right decisions. But how? How a car is capable of taking right decisions? It is based on intelligence. It is just because of intelligence, and that intelligence is given artificially. Okay, so if not only a car, any mission, if it is capable of mimicking human intelligence, it is nothing but application of artificial intelligence, AI, right? So under AI we have many subsets. Okay, so one of the subset is machine learning. What do you mean by machine learning, friends? What do you mean by ML? Hope you understood the terminology, artificial intelligence, right? Yes. So in the same way, what do you mean by machine learning? So the same, machines, if they are capable of learning the data, you know, the historical data that we have will be passed to the machine. So some people make it as model, algorithm, whatever it might be, you know. So these machines, if they are capable of learning the data, the historical data, without being explicitly programmed, that becomes machine learning. What does it mean? It means, over the time, for example, I want to predict whether a person have disease or not, or in simple, I'll make it very simple. So we generally, all of us have mail IDs. Yes, for sure a person will have a mail ID. Yes. How many of you get mails? Again, all of us. If you have an ID, obviously you'll get mails when you share across your connections. Okay, so obviously you'll get mails. So these mails, all of them are ham or spam. Because if you observe, we get both ham mails as well as spam mails. Okay, so spam mails are related to any kind of advertisements, you know again, not related to you. You may get some kind of spam mails, but ham mails are the mails that are related to you. Okay, so these ham mails and spam mails are generally observed for each and every person. So how you are able to identify whether it is a ham mail or spam mail? Simple. I'll go through the content which is present in the mail, and depending on the content that I have in the mail, obviously I can differentiate whether it's a ham mail or spam mail. Yes, but if I'm able to build a machine, if I'm able to build a machine, and this machine will be capable of predicting whether it's a ham mail or spam mail. So in simple, it will classify whether it is a ham mail or spam mail. That's it. But will the machine go through the content? Yes. you know when the historical data, when I pass say around 10,000 emails, I'm just taking a random number, friends. If I pass 10,000 mails, okay, in which we have both ham mail and spam mail, both I have. Okay, so when I pass both these mails to my model tries to understand each and every you know mail, the content that is present inside the mail. It goes through the content, and it is learning the patterns. It starts learning the patterns. If some particular words were being identified, it can recognize that it is a ham mail. If not, it is a spam mail. In this way, it starts learning the patterns. Okay, so we are not explicitly programming that. If you find, for example, this reviews, feedback. So if you find such kind of words, classify it as spam mail or anything else. So I'm not passing any of these words, but who is actually classifying? A machine, a model. How it is capable? By just learning the data. The patterns that are present inside the data, it starts learning them, and it is capable of classifying the output, whether it is a ham or spam. So that is the reason we say it as the capability, the ability to learn from the data without being explicitly programmed is nothing but machine learning. Machines start learning the data, the capability. You know, it starts the patterns, identifying the patterns, okay, without being explicitly programmed. Will not inform, being the end user, will not tell that, if you find these words, only then you classify. If not, classify in the other case. No, right? So that is what machine learning says, and machine learning is broadly classified into three types: supervised, unsupervised, and reinforcement. So friends, as I have discussed earlier, if you haven't watched our previous sessions on classification regression algorithm, we have two playlists available on our YouTube channel. One is on classification algorithms and the other one is on regression algorithms. So do watch these sessions, okay, to get good amount of knowledge on machine learning, because in real time supervised learning is used more compared to unsupervised learning. So that made us to do these algorithms, and we also have come up with some projects. Okay, so for each and every algorithm that we have discussed, we came up with a project, end to end. We have build the model as well, and we also evaluated the model, right? Now, as part of this session, you know whatever we are going to do from today till this particular week, we are going to understand deep learning algorithms. But what exactly is deep learning? What exactly is deep learning? Deep learning is subset of ML. ML is subset of AI, but DL is subset of ML. So that means I can say AI, DL is also subset of AI. Yes, obviously, right? So DL is being a subset of AI. What exactly is deep learning? Again, you see, we are using the terminology learning. So that means if you want to, work on complex data, huge amounts of data, okay, by using neural networks, deep learning algorithms uses the concept of neural networks to work on huge amounts of data, huge volumes of data to get the output. Okay, and these neural networks, they are similar to human brain. They are similar to human brain. How a human brain will work in a similar way, the functioning of neural network is also inspired. Okay, so let us talk about what is neural network. Okay, then what exactly are these neurons? What parts do we have under neuron? Okay, how it works and all we'll discuss. I hope you got some clear picture. AI, then in AI we have ML, under ML we have DL. Yes. Now let's get started, but before that we'll quickly cover the definition. So it is a subfield, nothing but a subset of ML as well as AI that uses neural networks. So it uses neural networks, and as it is having multiple layers, so these networks will have multiple layers. So that is the reason it can identify, the patterns to till the deep, to the depth, and it can model complex patterns in the data. So these particular neural networks are inspired by the structure and function of human brain. How exactly a human brain works, in the same way the neural networks were also built. Okay, so we'll discuss. Hold on. Regarding this particular point, we'll again talk in the upcoming slides. Yes. So if you see the key features of deep learning, it starts with hierarchical learning. Okay, starting from the simple patterns to the complex patterns, it starts understanding the learning journey. Okay, then it automates the feature extraction. So whatever relevant to the data is, it concentrates more on the data compared to the features that are not required, and it also performs scalability. Okay, so what exactly is this learning journey? We'll discuss. So let us get introduced to neural network. You see in the image, this is a simple neural network. Okay, so this is a simple neural network in which we have input layer, hidden layer, and output layer. What are these layers? What are these layers? Hold on. Okay, so we'll understand this particular network before, we'll complete that. What exactly is neural network? We'll talk. A neural network is inspired by the structure and functioning of human brain. Yes, like how a brain has, probably 8.6 crores of neurons. Okay, so it is crores. In short, it is 86 billion neurons. Just remember, calculate the number, friends. It has 86 billion of neurons connected with it. Okay, so in a similar way, our neural network is also designed. Okay, so it consists of interconnected layers. In a neural network, you'll have input layer, hidden layer, and output layer. Okay, so all these layers will be connected. You see, and in each and every layer, you will have neurons. Okay, so these are used for what is the purpose of neurons in human body? Why? What is the purpose of having neurons? They are helpful for, you know processing. If you want to process the information from one part to the other part, you need some important organs called neurons. So we have n number of neurons in our human body, and these neurons, all of them will be connected. See, I'll just give a small example. When you touch a hot object, what happens? Will you keep on holding that? No. Immediately, within fraction of seconds, milliseconds itself, the information gets passed to the brain. Okay, and immediately the brain also sends, the signals to the particular place. For example, if you're holding a hot object using your hand, okay, so the neurons that are present in hand will send the information to the brain that you are holding a hot object. So since we cannot hold hot objects, so what happens is your brain starts sending immediate response that, leave it or keep it on the table, whatever it might be. Okay, so within fraction of seconds, all these, information gets passed. So in the same way, we are going to replicate a human brain. Okay, so the neurons that are present in the human brain will be used, and these neurons will be in three different layers. One is input layer, hidden layer, and output layer. Okay, so in input layer, we'll have the neurons, and all these input layers neurons will be connected to the hidden layer neurons, followed by the neurons that are connected to the output layer. Okay, so these neurons are also called as nodes or units. Yes, they work together to process the input data and produce meaningful outputs. So this is how it gets trained in this way, right? Yes. So if you see here, what exactly does input layer has, and what can we have in the hidden layer, and what we'll get in the output layer, we'll discuss. So any neural network will contain especially three main layers: input layer, hidden layer, and output layer. Okay, so in the input layer, it receives the raw data. The raw data will be received in the input layer. Okay, for example, if you are going to uh, take an image, okay, so as image cannot be represented as it is, so what happens is the image that you are going to pass through this neural network, this gets converted to pixels. This gets converted to pixels. So this image which is converted to pixels, will be passed to the input layer. If not, if you are working on a data set, okay, if you are working on a structured data set, obviously the features, whatever the inputs that you have, the features will be taken into the input layer. Okay, so each neuron in this particular layer, they represent a feature in the input data. Example again. For example, I want to predict whether a student will pass or fail. Okay, this is my output. And for this, I have some inputs like x1, x2, so on, probably x3. So, how much time they are studying, preparation time, obviously. Then x2 will be my, you know, uh, do they attend classes on daily basis or not? Probably their attendance percentage is what I consider. Then x3 will be my amount of time invested on social media. So let me take all these inputs and I'll predict whether a student will pass or fail. So input layer, what are the inputs that I have? X1, x2, x3. So three features will be passed through the input layer. So obviously you'll have three neurons. It's not four, friends. This is your Y. In Y class, in your output column, you have pass fail. Okay. So I'm not talking about Y. In the input layer, each neuron should represent a feature of inputs. In your data, you have inputs, right? So these inputs will be passed in the input layer. Then coming to the hidden layer. In hidden layer, where do we generally have the hidden layer is between input layers and output layer. Okay, so what is the purpose of hidden layers? They help us to perform computations on the data. So, once the data starts passed to the neural network, identifying the patterns, okay, then getting the insights, Everything will be done in the hidden layer itself. The patterns identifying will be done in the hidden layer itself. Okay. How many hidden layers should we have? Is the general question that we'll have in the mind. Because for sure we'll have only one input layer and only one output layer in a neural network. But number of hidden layers can increase. It can be one, two, so on. You can have n number of hidden layers, and just because of having n number of hidden layers, the model, the neural network complexity increases. That's what it was written here. How many hidden layers and neurons you are going to have in the hidden layer is going to decide your model complexity. If you have more hidden layers, the complexity of the model will be high. If you have less hidden layers, obviously the complexity gets reduced, right? So one more question. So Akhil, it's clear that I can have more than one hidden layer. Probably I can have two, three, so on. But in these hidden layers, again, how many neurons can I have? Can I have only four every time? No, friends. You know, the number of neurons that you would like to have in your hidden layer, you know, it is also up to us. When you are going to define your neural network, upfront you can come up with number of hidden layers as well as number of neurons in each hidden layer can be decided by us. So these two, the layers, hidden layers, and the number of neurons in each and every hidden layer will define the complexity of the model. Okay, if you have more, obviously the complexity gets high, right? And finally, the output layer. In the output layer, obviously you're going to get the output. So as part of the output layer, you'll get the output, and depending on the use case, if it is a classification problem, it classifies whether pass or fail. If it is a regression problem, it gives the directly the value. It predicts the continuous value. Okay, so the output layer is actually producing the result, the final result, and the number of neurons to be part of the output layer is, depending upon the problem. If it is a regression problem, obviously one neuron is enough. But if you are working on a multi neuron, multi classification, then obviously you should have more than one neuron, right? So this depends on the project or the use case that you work. This is not fixed. So I hope it's clear. In a neural network, you'll have three layers. Let us quickly revise. We'll have three layers: input layer, hidden layer, and output layer. In the input layer, the neurons that we have represents the features of the data. Okay, if you are talking about structured data, the inputs that you will have will be passed through each and every neuron. I'll take an example: 100 rows, 10 columns. Okay, in these 10 columns, if you say that you have 9 inputs and 1 output, so in input layer, how many neurons should you have? 9 neurons. Because each and every input will be passed through each and every neuron. Okay, then followed by hidden layer. Hidden layers, what is the purpose of using hidden layers is the patterns, the underlying patterns within the data will be understood, will be recognized by the hidden layer neurons only. And the complexity of your model will be completely dependent only on hidden layers. If you have more hidden layers and if there are more number of neurons in the hidden layers, the complexity increases, right? And finally, the output layer, which is where we get the final output, whether it is a classification problem or a regression problem. Accordingly to the use case, you are supposed to finalize the number of neurons. That's it. Now let us understand a few terminologies that we keep on using. So I'll talk about these particular terminologies again, but before we understand how a neural network works, we'll quickly have a basic idea about these important components of a neural network. A neural network, in a neural network, we'll use weights, bias, activation function, and loss function. What are these? We'll understand one by one. Weights. These weights, they are actually helping us to have a connection between neurons. Okay, so between one neuron and the other neuron. Okay, if you would like to have a connection and if you want to pass the information from one neuron to the other neuron, obviously that will be communicated by weight. Okay, I'm going to use a parameter, a component called weight, and this particular weight will help us to have the connection between the neurons. Okay, so each connection between the neurons will have weights. So this is just an elaborated process. Okay, don't assume that it's a complex neural network architecture. It's a simple one. We have elaborated it for better understanding. Okay, then probably you'll be clear on it. Then bias. So at each and every connection, we'll add a parameter called bias. Okay, so to the weighted sum to shift the activation function. Okay, so what is this activation function? This activation function helps us to, you know, pass the data from one neuron to the other. Okay, and the common activation functions that we use are ReLU, sigmoid, tanh, softmax. Then we have multiple, and these are the common used activation functions. And finally, the loss function. Okay, so this measures the difference between the predicted output and the actual output. Okay, so for example, if I'm working on a regression use case. Okay, so regression. So obviously, I'm predicting a continuous value, right? So when you're going to predict a continuous value, what will be your output? Again, it will be a continuous value only, right? So for example, my predicted value is 9.5, but my actual value is also present, right? Because I'm training my neural network. So when I'm training my neural network, I'll have historical data. In my historical data, I'll have y, my actual value. My actual value is 10, but my predicted value is 9.5. Actual minus predicted will give you loss. What is the value? 0.5. 0.5. So some of the common loss functions that we have is mean squared error. So I have discussed what is this mean squared error and cross entropy loss in our previous playlist with respect to regression and classification. So friends, if you haven't gone through our previous sessions, do watch our previous playlist so that you'll have a good understanding regarding whatever we are discussing now. Between each and every topic that we'll be discussing from today, we'll have a connection, right? So that is the reason we started from basics. These metrics were already communicated. They were being discussed in our previous playlist. Do watch them, right? So mean squared error and cross entropy loss will be generally used as loss functions for regression and classification tasks. Okay, so we'll discuss these components once again, but now let us understand how a neural network will be trained. Okay, right. You see here, probably I'll draw for better understanding. 1, 2. I'm taking a small neural network, friends. Okay, in which I have input layer, hidden layer and output layer. So this is my input layer and this is my hidden layer and finally output layer. Okay, so this is my small basic neural network in which I'll start. Now let us understand this neural network, how it learns, okay, how it works actually. So if you see here, initially we will be passing inputs to our neural input layer. The neurons that are present inside the input layer, we will be passing our inputs x1, x2. Assume there are only two inputs. Okay, so two inputs should be passed to two neurons of input layer. The neurons that are present in the input layer will get the information, will get the data of x1 and x2 respectively. Then what happens once after getting the data to the input layer, what happens to the next hidden layer? Between input layer and hidden layer, the weights get added. The concept of weights get added. What is this weight? Weight is again a small number that gets added, you know, in order to pass the information from input layer to the hidden layer, we use weights and bias. Okay, so what happens is when the weights get added, okay, so the value that you will have to the input neuron will be multiplied by the weight, okay, and that particular weight will be summed up with the bias to get the output of the next neuron in the hidden layer. In short, let me take this particular neuron. So this particular neuron is connected with both the inputs. Yes, it has both the connections. So what information should be passed to this particular neuron? Let us understand. It uses, this particular formula. It uses this particular formula to get the information in this neuron. So how it is going to get the information? X1 will be multiplied with W1. Then what is this the only connection? No. I also have one more connection coming from the second neuron of input layer. So you will have X2 multiplied with W2. Second input will be multiplied with second weight. So don't assume these weights are constant. Each and every connection will have a weight. And these weights initially they are randomly assigned. They are randomly assigned. Okay. So this will ensure to give the value in our next neuron. To the next neuron, we'll have the value. And we'll also add bias. So why should we add bias? We'll discuss. So this will be the output for the summation function. What is the summation function? A neuron will have two parts, friends. This is very important. Understand. A neuron will have two parts. One is summation function and the other one is activation function. Summation function and activation function. How is the summation function calculated? Simple. Xi multiplied by Wi. Okay. Summation of I equals to 1 till n. Depending on number of inputs that you have, okay, depending of number of neurons in the input layer you have, all the values will be multiplied with the respective weights, okay, and these will be getting added. I'm using the same formula but representing in a different notation. Okay, to this bias gets added. To this bias gets added and this will be the output for summation function. So summation function will be calculated in this way. Okay, so summation function will be calculated using this formula. So once if you have some input to this neuron, so this should also pass the value to the other neuron. Yes. For that we are going to use activation function. Whether this particular neuron should be activated or not should be understood, right? So this activation function, we have multiple types. We have ReLU, we have sigmoid, then tan H, softmax, n number of activation functions are used, and this, you know, for this activation function, the output of summation function will be passed. I'll get a value here, obviously, yes. So this value will be passed to activation function. Probably take it as Z. So when you pass this value to the activation function, you'll get again an output, and that output will be multiplied with one more weight, because there is a connection to the next layer, output layer, right? So it keeps on happening. Okay, in this way, the neural network gets trained from input layer. It passes the information to the hidden layer. In the hidden layer, it understands the patterns, okay, by performing the summation and the activation. Okay, once after performing the activation, whether that particular neuron should be activated or not will be decided, and then the information will be conveyed to the next layer, that is output layer. In this way, it propagates forward, and this is nothing but forward propagation, the first step of neural network. So now let us explain with the steps. Input data is passed to the layer by layer. That's what it does. Okay, once if you have the input layer, that will be passed from one layer to the next layer. At each neuron, after the input layer, if you see at each and every neuron, it initially calculates what? Weighted sum. That is nothing but summation function. How is this weighted sum calculated? Using this formula. It multiplies the values that you get from the input layer with the weights, corresponding weights. In that way, all the weights will be multiplied with the inputs, and they get summed up, and this particular output is nothing but weighted sum. Okay, so this weighted sum will be passed to the activation function. So this activation function, it introduces the non-linearity. Okay, whether that particular neuron should be active or not will be decided, and then finally the output will be given to the, you will get the output from the output layer. When you repeat the same process, you will get the output, and this output you have to compare with your, this is predicted, right? Compare with your actual. Okay, so if I say, if I assume that if I'm working on pass fail use case, student will pass or fail. So what is the output that I'll get? Obviously pass or fail. Assume my neural network predicted, okay, assume it has predicted pass. What is my actual? Because when I pass this data, I'll also have my actual data, right? Actual y. So compare. My actual y says false, but my model says pass. Okay, sorry. My actual value says fail, and my model says pass. So that is a wrong prediction. A wrong prediction. In this way, we calculate loss. Loss is nothing but actual minus predicted. Okay, so this actual minus predicted will be calculated to get the loss function. Once if you have the loss function, this loss function should be very small. Only then the model, we can say that the model have trained well, we can say that the neural network have learned a lot of pattern. So that is the reason the loss function is very small. But what if the loss function is very high? Even though if it is small, we'll go and do one more step. It is called back propagation. The neural network starts back propagating, like however it have trained, in the same way it starts propagating back. Why it should back propagate? It should back propagate because to reduce the error, nothing but the loss that was calculated, this particular value should be very small. That is what our objective, right? Okay, see, if my actual value is 10, okay, in my output, and if my model predicts as 10, so obviously it is a right prediction. So what is the error that you get? 0. So is it very high? No, it is very low, small. So that means whenever your value, your prediction is exactly matching your output, your loss function will be very small, right? So this is our objective. Our objective is to make our loss function we have to minimize it. This can be done by the neural network when it starts back propagating. What happens when the model back propagates? Why the model should back propagate is, to reduce the error. Okay, once after calculating the error, this error that we got, has to be reduced, right? For that reason, it back propagates. When it back propagates, the weights that are randomly assigned and the bias, I'm talking about both weights and bias that are randomly assigned, should be minimized. My bad, should be recalculated because they are randomly assigned, right? So that is the reason you're getting this output. So in order to reduce my error, what I'll do is I'll back propagate. The neural network starts back propagating. And when it starts back propagating, the weights and the bias get updated. How it get updated? It uses a different formula, and using that formula, it starts updating the weights and the bias. Okay, so that is where we use the optimization algorithms like gradient descent. Gradient descent comes into the picture, friends. Okay, so using this gradient descent, we are going to minimize the loss function, adjusting the weights to the local minima. So we are hearing new terminologies, no issues. All these, new topics we are going to understand. What is this local minima? What is gradient descent? You'll understand. Right. So once if the model back propagates and the weights are calculated, so I'll get new weights. Probably I'll get new weights, doubly new. Okay. So once if the weights are recalculated, again the model starts training. Okay. Again the model starts forward propagating, and this time again the same process. The input values will be multiplied, okay, with the weights, and the bias get added, and the activation function will get the value, this weighted sum, and this activation function helps us whether the neuron has to be active or not, and sends the value to the output layer. In this way, again the loss function will be calculated, and this propagation happens. So till when? Until you get, you know the desired output. So this is nothing but your neural network journey. Okay, so both forward propagation and backward propagation is what it undergoes during the training process. Okay, so we also have a few more terminologies like epochs, batch size, iterations. I'll not discuss them here. I'll talk about all of these in gradient descent algorithm. Okay, so this gradient descent is an optimization algorithm which helps us to, update the weights. The new weights, the new bias that we get, okay, will be calculated using the gradient descent algorithm only, friends. Okay, so what is this gradient descent algorithm, how it works, we'll discuss in the next session. But few more things I would like to communicate. Yep, not weights and bias. I'll just give an introduction to activation functions. No, not required. Right. So what did we learn in today's class? We understood the overview of deep learning, then the layers, A neural network, a basic neural network is what we understood. Okay, then how it works. The working principle of neural network is understood. Okay, if you see here, feed forward is representing nothing but your forward propagation from the inputs. Okay, from the input layer it starts propagating, the values will be multiplied with the weights, and to this output the bias get added, and that will be your weighted sum to the next layer inputs. Immediately this particular weighted sum will be passed to the activation function that is being used, and the activation function will give you an output, and that output will be multiplied with the weights, corresponding weights, and the bias will be added, and this will give you the output. So this is just a small basic neural network, right? All of us are using GPT, chat GPT, right? Yes, Google Gemini. What are these? These are nothing but transformers. What are transformers? Transformers are nothing but neural networks. So whatever we are using in the real world with respect to AI is a neural network. I'm talking about strictly about deep learning concepts, friends. Okay, so this is the foundation of neural networks are the foundation of deep learning algorithms. So if you are clear on the topics of neural network, you can understand any type of neural network. That would be easy because if you are clear on the foundations, you can learn any type of neural network. GPT is a type of neural network. Then BERT is a type of neural network. CNN, RNN, LSTM. Okay, we have GANs, we have autoencoders. All of these are neural networks only. So friends, I knew that this neural networks is a new topic, and it's not possible to understand in one single go, you know, until you are clear on the basics. Keep on, watching the session. Okay, have a clear cut note. Okay, make your notes, describe all the important points, and probably tomorrow we'll have lot of information. Okay, we'll discuss activation functions. Then we also discuss, optimization algorithms, especially gradient descent, how the weights get updated. Okay, what is this optimization algorithm, gradient descent also we'll understand. Right. So I'll stop here, and it's time for questions. Right. So if you have any questions, do share your questions here. And before you leave, we have the feedback link provided. Share your valuable feedback, as well as do hit on the like button before you leave. Okay. Also share across your connections. Ask them to learn the important topics of artificial intelligence. It is neural networks, and you can if you're joining for the first time, we also have done lot of sessions with respect to ML, Python, SQL, Power BI. All of them were being covered. So just go through the sessions. Right. So that's all for the day. Again, we'll meet in the next session. Until then, take care. Have a great day. Signing off.